Today we're going to discuss about OpenCV object detection and Python bindings using OpenCV. First, I'm going to discuss about object detection. The goal is we will see the basics of the face detection using HR feature-based cascade classifiers. Second, we will extend the same for eye detection and etc. So the basic object detection using HR feature-based cascade classifiers is an effective object detection method proposed by Paul Viola and Michael Jones in their paper Rapid Object Detection Using a Boosted Cascade of Simple Features. Here we will work with the face detection. Initially, the algorithm needs a lot of positive images, 4 images with faces, and negative images without faces to train the classifier. Then we need to extract features from it. For this, HR features shown in the image are used. So they are just like your convolutional kernel. Each feature is a single value obtained by subtracting sum of pixels under a white rectangle from sum of pixels under black rectangle. Here we have 3 features. We have the edge features, which is down. The bottom is black. The right part is black, and we have line features, which the middle part is black, and horizontally and vertically. And then we have 4 rectangle features, which the top right is black, and then the bottom left is black. Now all possible sizes and locations for each kernel is used to calculate plenty of features. Just imagine how much computation it needs. Even a 24 by 24 windows results over 160,000 features. So for each feature calculation, we need to find the sum of the pixels under white and black rectangles. So to solve this, they use the integral images. So we have here example, but among all these features we calculated, most of them are irrelevant. For example, this image below, this image shown. So the top row shows two good features. Here, it identified the eye first using the features that we have discussed earlier to train the classifier. So we have here the negative and positive side of the images, and then we select the features with minimum error rate, which means they are features that best classify the face and non-faces images. So also, the process is continued until the required accuracy of error or error rate is achieved, or required number of features. So after that, we will declare a variable image equals cv2 that I'm read parentheses, then name of the image, you can name it searching.jpg. Then we declare gray variable equals cv2 dot cvt color. Then let's pass image as parameter, then declare comma cv2 dot color bgr2 gray. Now we find the faces in the image. If faces are found, it returns the positions of detected faces as rect, x and y axis, and then width and height, the parameters of rect. Once we get these locations, we can create a ROI or ROI for the face and apply eye detection on this ROI since eyes are always on the face. So faces, we declare variable faces equals the face cascade we declared that detect multi-scale. Then we pass the variable gray in the parameter and then declare 1.3, then 5 then let's declare a 4 for x and y axis, and then width and height of the rectangle. In faces, image is equal to cv2 that rectangle. Then let's pass the variable image to the parameter, then the x and y enclosed with parentheses, xy, then xw, x plus w, and then y comma y plus w. So another parameter is the color 255, which means the first is red. So and then we have 2, the last parameter. So we should declare ROI gray variable for the color gray. Then let's call the gray variable that we have declared above. Then let's bracket y colon y plus h, then comma, let's do for x plus w or width, and we do also to the color. So let's call the image variable we have declared, and open bracket, then same values inside with the gray or ROI gray, and then we have eyes, declare eyes, and then we call eye cascade, which we have declared above, eye cascade that detect multi-scale, then open parentheses, let's pass the variable to the parameter, the variable ROI gray. Then we look for x, let us say let's declare x, then u, e in eyes, then enter, then the cv2 that rectangle, ROI color, and then x8. So let's just copy the code. Yep. Then after that, outside the for loop, we declare cv2 that I'm show to show the images. Let's put a name of a frame. Let's say example, hey, image, and then we pass the variable image that you have declared above, and then CV2 enters CV2.wait key until it's like a time to show the frame. And then CV2, let's just put 0 in it. Then CV2 that destroy all windows, except for the frame. So we have here run, and then F5, save. So you can save it anywhere, the location, and then the result would look like this. Here we have the color blue, which represents the detected faces. We have the green, which represents the detected eyes. So that's how you detect objects using OpenCV. So basically, you just need the classifiers, the OpenCV, the NumPy, and the XML files, the image to detect, and you just have to declare get the images, show the frame, and view the results. So that's it, and we will proceed to our next step. Now let's proceed to our cascade detection in OpenCV. OpenCV comes with a trainer as well as a detector. If you want to train your own classifier for any object like car, planes, and etc., you can use OpenCV to create one. So in full details, of course, you can go to Cascade Classifier Training for more information. Here we will deal with detection. OpenCV already contains many pre-trained classifiers for face, eyes, smile, and etc. Those files are called XML files, and it's stored in OpenCV data /HR cascades folder. Now, after finding the files, let's create face and eye detector with OpenCV. So first, we need to load the required XML classifier. Then we load our images in grayscale mode, so we have to import numpy. Create a new file. Import and import. Let's also import OpenCV, which is CV2. Then let's declare a variable face cascade _cascade equals. Let's call OpenCV that cascade classifier, then parentheses, and then let's declare the name of the cascade, the XML. Let's R cascade frontal face. Just copy the text. And then let's also declare for a variable for I cascade. Do that. Let's copy and paste. Same line of code. And then the name of the HR cascade XML. Then after that, we will declare image equals OpenCV dot cv2 dot imread. Ay, okay lang ako.
Guys, my name is Stanley Oropa, and my topic today is OpenCV bindings. So what is the goal of OpenCV bindings? First is how OpenCV Python bindings are generated. Second is how to extend new OpenCV modules to Python. So how OpenCV Python's bindings are generated? In OpenCV, all algorithms are implemented in C++, but these algorithms can be used from different language like Python, Java, etc. This is made possibly by the bindings generators. These generators will create a bridge between C++ and Python, which enable users to call C++ function from Python. OpenCV to Python by writing the wrapper functions manually is a time-consuming task. So OpenCV does it in a more intelligent way. OpenCV generates this wrapper function automatically from the C++ headers using some Python scripts which are located in modules Python is RC2.
As a continuation about the OpenCV bindings, first, in module Python, CMake files.txt is a CMake script which checks all the modules to be extended to Python. It will automatically check all the modules to be extended and grab their header files. These header files contains list of all classes, functions, constraints, constants, etc. for the particular modules. Second, the header files are passed to a Python script module Python source Jann2.py. This is a Python binding generator script. It calls another Python script module Python source header parser.py. This is a header parser script. This header parser splits to complete the header files into small Python lists. So this list contains all the details of a particular function, classes, etc. For example, a function will be parsed to get a list function name, return type, input arguments, argument types, etc. Final list contains all the details of all functions, structs, classes, etc. in that header file. But header parser doesn't parse all the function classes in the header file. The developer has to specify which functions should be exported to Python. For that, there are certain macros added to the beginning of this declaration which enables the header parser to identify the functions to be parsed. These macros are added by the developer who programs the particular function. In short, the developer decides which functions should be extended to Python and which are not. Details of these macros will be given in the
So header parser returns a final big list of first functions. Our generator script will create wrapper function for all the functions, classes, enums, structs parsed by header parse. You can find this build modules Python compilation by OpenCV generated folder as files. But there may be some basic OpenCV data types like math, vic, 4i, size. They need to be extended manually. For example, a math type should be extended to numpy array. Size should be extended to a tuple of the two integers. Similarly, there may be some complex structs, classes, functions which need to be extended manually. To such manually, there are module Python source to pycb2.hp. And so now, only thing left is the compilation of this wrapper files which give us CV2 module. So when you call in Python, you pass two numpy arrays and you expect another numpy array as the output. So these numpy arrays are converted and then calls the function in C++ or on the Python result will be converted back into a numpy array. So in short, almost all operations are done in C++, which give us almost same speed as that of C++. So this is the basic version of how OpenCV Python bindings are generated.
Good day. Um, how to extend new modules to Python. Header parser parse. The header files based on some wrapper macros added to function declaration enumeration constant don't need any wrapper macros.
As shown in this code below, for large classes also, cb_exports_w is used. To extend class methods, cb_wrap is used. Similarly, cb_prop is used for class fields. Overloaded functions can be extended using cb_exports_us, as shown in this code below. But we need to pass a new name so that each functions will be called by that name in Python. Take the case of integral functions below. 3 functions are available, so each one is named with a suffix in Python. Similarly, cb_wrap_us can be used to wrap overloaded methods.
So in addition, this code below are small classes structs are extended using cb_exports w simple. These structs are passed by value to C++ functions. Examples are key point, match, etc. Their methods are extended by cbwrap and fields are extended by cbprop rw. So some other small classes structs can be exported using cb_exports wmap, where it is exported to a Python native dictionary. Moments is an example of it. So these are the major extension macros available in OpenCV. Typically, a developer has to put proper macros in their appropriate position. Rest is done by generator scripts. Sometimes there may be an exceptional cases where generator scripts cannot create the wrappers. Such functions need to be handled manually. But most of the time, a code written according to OpenCV coding guidelines will be automatically wrapped by generator scripts.